Okay, everyone. Welcome to the last section of videos. So we're gonna just cover chapter 10 here, which is general equilibrium and economic welfare. We're gonna just cover this a little bit briefly. We're just gonna talk about the first two sections. But as always, I'll lead off with the section overview of everything. So first, general equilibrium is just going to be like a shift in government policy or other shock in one market often affects other markets as well. And so trading between two people, when two people have goods but cannot produce more goods, both parties benefit from mutually agreeable trades. Competitive exchange and the competitive equilibrium has two desirable properties. A competitive equilibrium is Pareto efficient, which we're going to get into what that means here. And I think the first video. Um, any competitive equilibrium is Pareto efficient, and any competition can result in Pareto efficient allocation given an appropriate income distribution. Production and trading, the benefits from the trade continue to hold when production is possible, and efficiency and equity, because Pareto efficient allocations are possible, a society may use its views about equity to choose among them. So let's get into just some general equilibrium stuff. The general equilibrium now just it's this big kind of abstract concept that essentially says that when we like so far we've only used partial equilibrium analysis, which is just an examination of equilibrium and changes in equilibrium in one market in isolation. And so in partial equilibrium analysis, we hold prices and quantities of other goods fixed. We implicitly ignore the possibility that events in the coffee market might change the effects in the tea market. And when stated badly, this partial equilibrium analysis kind of sounds like naive and a little foolish. Um, but it need not be, right? So suppose if we had like a government that puts a specific tax on some good, if the tax is sizable, it's going to affect that good, but it also could affect other markets as well. And so sometimes we need to use a general equilibrium analysis. And this is the study of how equilibrium is determined in all markets simultaneously. So, for example, the discovery of a major oil deposit in a small country would raise the income of its citizens and increase in income effects of all of the country's markets. And so sometimes this is called a multi-market analysis, sometimes it's just called general equilibrium. This is essentially like an explicit consideration of spillover effects. General equilibrium models analyze the economy as a whole. It deals with the interrelationships of markets. And so the interrelated markets, we can choose the price and quantity in two different markets by solving supply and demand curves for related markets simultaneously. It was developed by this French economist Leon Walras in the in the 19th century. But the main essence is that all free markets tend towards the equilibrium in the long run. And so in the long run, we should be able to have harmony amongst the markets. So the demand side, you have one representative consumer choosing between two goods. On the supply side, you have two or more firms producing one good. In a general equilibrium model, we're going to have two representative people, a consumer and a producer, and two goods. And so this leads to the rise of this concept called Pareto improvement and efficiency. And so this was developed by the Italian economist and sociologist Vilfredo Pareto. And a Pareto improvement is any change in the economy so that everybody is at least as well off and somebody is strictly better off. So if we think about the game theory perspective, if we had two ideas that were the same, and one person could improve from moving from action one to action two while leaving the other person just kind of neutral, then that would be an Pareto improvement for one individual. So, in other words, a Pareto improvement occurs when a change in allocation harms no one, but benefits at least one person, given an initial allocation of goods for a set of persons. So, can you think of any examples? One example for me might be that suppose I have a coffee and Sam has a coffee. Well, I have two coffees. Um, I might feel a little overwhelmed if I had two coffees and Sam had one coffee, and I might feel bad that this other person would have a coffee. So actually, I'm going to be just as fine with one coffee as another. So I might give this coffee to somebody else so that we could be more equitable in the long run. Um, But there's so many other examples out there in the world. So if we want to think about allocations, we call something Pareto efficient if it is impossible to reallocate goods and make one person better off without making the other person worse off. So this would be called also consumption efficiency. So if we think about this, and what if we suppose that all three of us already started with a coffee? and we all like coffee, so we're all going to be positively benefited. If I were to take this person's coffee and give it to myself, so they were left with zero and I was left with two, then that allocation would not be Pareto efficient because that reallocation of goods would make the person with no coffee now better off. So it's impossible to make a party better off without making somebody worse off. And it's going to maximize the size of the total welfare without losers, or without losses. Sorry, not losers. Um, so targeting Pareto efficiency is going after the lowest hanging fruit, and it's going to be the easiest, the least controversial policy option for everything. And so some examples of Pareto efficiencies. So suppose that we were building a new airport, and let's assume that there's some winners and there's some losers. The private and external benefits are assumed to be $20 billion. The cost of building the export is $13 billion. Residents living nearby see a potential loss of welfare in $1 billion due to pollution, congestion, noise. So the net benefit to society is $14 billion. So that's a clear gain of $6 billion. Is this Pareto efficient? It is not because those living nearby lose out. Even though that it is a positive benefit to like in net to society, the people living close by to that airport are having or experiencing a significant loss. And so they would be worse off with the construction of the airport, even though everybody else would be better off. So what should we do? The scheme has a net welfare gain, but some lose out. And so one option would be to make the airport company compensate local residents for the inconvenience of losing out and having the airport be built nearby. So essentially compensate them for some of their losses. That's one example of how uh, governments may step in and improve and capitalize on Pareto improvements when possible. But there are lots of other options that could happen as well. Maybe there's a different site for which the airport could be built that may cost a little bit more, but it wouldn't harm anybody else because maybe it's just further off into the distance. Think like the Denver airport. It's kind of out there in the middle of nowhere. And so that would also be another way to improve, make a Pareto efficient allocation is to make somebody not worse off, but just make, I mean, it's going to be a positive benefit everywhere because we're going to be building an airport, but it would not harm somebody. And so here's another example. So determine whether the following situations are Pareto efficient. So suppose that we have 10 books and Alice and Bob both like books. They have zero to begin with, and I have to figure out a way to give out 10 books. So if I give Alice four books and Bob six books, that is a Pareto efficient improvement. Alice is going from 0 to 4, and Bob is going from 0 to 6, both of which are positive gains. And so we're good. Similarly, this allocation is also Pareto efficient. Going from 0 to 10 for Bob is obviously an improvement, but um, going from 0 to 0 does not make Alice worse off. And so, since both of these are Pareto efficient, both of these allocations would be beneficial in a general equilibrium setting. And so, one key thing to keep in mind here is that Pareto efficiency does not consider equity. So, just because one thing might be unequal doesn't mean that it is not Pareto efficient. As long as nobody is worse off, something is a Pareto efficient. So let's do another example. Suppose that there are 10 chocolate bars and five people: Alice, Bob, Harry, Miko, and Maya. Everybody prefers to have chocolate bars except for Miko. Miko prefers to have fewer bars. Determine if these allocations are efficient. So again, let's assume that everybody starts from zero. So let's go Alice, Bob, Harry, Miko, Maya. So going from 0 to 2 for Alice is good. 0 to 2 for Bob is good. 0 to 2 for Harry is good. 0 to 2 for Maya is good. But 0 to 2 for Miko is bad because he prefers to have less. And so this is not a Pareto efficient allocation. However, if we go 0 to 0, 0 to 0, 0 to 0, 0 to 0, 0 to 10, this is a Pareto efficient outcome because this is neutral, this is neutral, this is neutral, this is neutral, this is good. As long as there's only green, then we're good. If we've got green, 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 red, then that's bad, and that's not a Pareto efficient outcome. So when we start to think about this, we can start incorporating a welfare perspective. And a welfare perspective helps us think about society as a whole. Economic welfare, in short, is just how much of a benefit are we going to generate for the entire market um, when we're looking at potential outcomes. And so any competitive equilibrium is going to be Pareto efficient. So if we have supply equals demand, that is going to be Pareto efficient. And that's their first theory of welfare economics. The second thing is that any Pareto efficient allocation can be seen by lump sum transfers and competition. So if we remember, competition forces people to move together towards that competitive equilibrium, which is then ultimately Pareto efficient. Or if we had one person that was significantly less worse off than the other, we could do a lump sum transfer from one person, essentially take out the competition, and we would still be able to reach a competitive equilibrium, which would allow us to generate some better economic welfare in the long run. But this is a strict assumption because perfect competition requires complete information. And like we saw in game theory, lots of times these markets don't have complete information. And so these are kind of strict assumptions to do so, but we may be able to stumble upon it just by using the invisible hand. So let's do something like this. Suppose we were given $100. In scenario one, I'm with 15 of my friends. So there are like 15 of you guys. There are 99 point, I get $99.85, and each of you guys get 1 cent, assuming that there's 15 of you. So there's 16 of us total. So in this, um, scenario A, this is a Pareto efficient outcome. And here's why. We are spending the entirety of this $100, right? Everything is going here. Oh, sorry. That should be a check mark. In scenario B, we're all going to get $5. So each of the 16 of us are going to get $5. And so that means that there's going to be $80 total. So what do we do with the other $20? Because that is not being used, it's not efficient because the entire allocation is not going to be the same. Now, if I gave myself $25 and I gave each of you guys $5, that would be a Pareto efficient outcome. And so that's kind of the concept of economic welfare in a very, very short way to describe it. And so we're not going to go super far in depth into this chapter because it has a potential to get into the weeds. But that's the end of video one. And we will jump into video two and start looking at a little bit of math with this. And we're going to talk about things like Edgeworth boxes. But really, we're going to talk about how we can work between two people to generate positive spillovers into welfare. So thanks for watching, and I'll catch you on the next video.